Hello every knowledge seeker, this is Remedial Tutorial Academy. For this video, what I want to do is show you how to determine if an argument is valid or invalid using a truth table. In order to be valid, at the end of the truth table, you have to end up with all true statements, which is known as a tautology. In order to be invalid, if you can show that it's false at any point, then it is going to be an invalid argument. All right, so we have two premises followed by a conclusion. The first premise is that if a student is a sophomore in high school, then they are in 10th grade. The second premise that we have is if a student is in 10th grade, then they have to take the PSAT. Our conclusion is that if a student is taking the PSAT, then they are in 10th grade. So in order to do this with a truth table, what you first must do is define each of the statements symbolically. So you're going to set up a variable to represent each statement. So I'm going to let P represent this statement, is a sophomore. I'm going to let Q represent the statement, they are in 10th grade. And since we have a third statement, R, we're going to let that represent take the PSAT. Okay, so we're going to go through and write each of these statements in symbolic form. So our first premise is if a student is a sophomore, so if P, then they are in 10th grade. So then Q, so that's our first statement. Our second statement is if a student is in 10th grade, so that's if Q, then they take the PSAT, which is R. And our conclusion, we use these three little dots to represent therefore.
Our last statement is if a student is taking the PSAT, which is R, then they're in 10th grade, which is Q. So you want to keep track of all of your statements that you are given. All right, so what we want to do is we want to take and create a truth table for this statement that if P then Q and Q then R, if this is true, then R then Q is a true statement. Okay, so our final column is going to be this long statement. So what we're going to do is we're going to start with the three variables that we have. So anytime you have a truth table, you always start with your given statement. So we have P, we have Q, and we have R. So we don't have any not statements, so we don't have to add any negations of any of these. And then we would just go through and fill in these columns. P is always, or your first statement is always going to be true, 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 followed by four falses. Q is always going to be true, true, false, false, true, true, false, false. So it's two truths, two falses, two truths, two falses. And then the last column is always going to be true, false, true, false, true, false, true, false. So when you're setting up for three statements, you will always start the same way. All right, so to continue on, what we are going to do is our next column is going to be our first group. So our first group that we have is the implication P then Q, or you could call this a conditional statement. Remember that this is true in every situation except for when the if part is true followed by a false then part. All right, so what we have is if P then Q, so we're going to look at our P column and then we have to look at our Q column. So we have to start with P and then look at Q. So true, true is going to be true. True, true is true. True, false, this is when it's going to be false because we have a true if then part followed by a false then part. True, false, false, true, false, false, and false, false. So remember, if P then Q is only false if you have the combination true followed by false in that order. Okay, our next column, we're going to look at our next group. So we need a Q then R. So that means that we're going to look at this column for Q followed by an R column, okay? So for this one, we have true, true, which is true, true, false, which is false, false, true, false, false, and I did that one. Hold on, let me go back. I caught myself. So true, 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 false is the only time it's false, false, true is true, false, false is true, true, true is false. That's the only time it's false. And then we have true and true. Okay. Now we're going to put together this whole first group. So the next one would be the P then Q and Q then R. Okay, so for this one, we're going to look at the two columns, P then Q and Q then R. Remember with and, this means that both must be true to be true. So true, true is true. True, false, they're not both true, so we would say this is false. False, true is false. False, true. False, true. True, true is true, true, false is false, and true, true is true. So if they're both true, then we would assign a value of T to this column. If they are not both true, then we see that it is false. All right, so now we need this group, R then Q. So we haven't done that column yet. So we need R then Q. Okay? R then Q means that we're going to start with looking at R, and then we're going to go to the Q column. So we're going to look for it this way. So I would start with true and then true, false and then true, true and then false. Remember, that's where it's false. False and false is true. True and true is true. False and true. True and then false is our false statement. And then false and false. Okay, so remember, for then, the only time it's false is if we have the pattern true and then false. So for this one, we had true and then false. And for this one, we also had true and then false. Everywhere else, it would be true. All right, finally to the last column. So remember with this, that our last column is going to be the entire statement. So we're going to put together the P then Q and Q then R. Then we have the group R then Q. So by setting it up the way that we did, we're going to look at this column here first, followed by this column here. So you don't have to look at all of the individual things. You can just look at the columns. So we have true and then true, which is true. False and then true. False and false. False and true. True and true. False and true. And then right here, we have the combination true and then false, which leads to a false statement. So since we showed that at one point, we can find the false statement that this is not a tautology, which means that we have at least one is false. So anytime this happens, then you would say that this is an invalid argument. So it's invalid if you do not end up with a tautology at the very end of your truth table. So this is a very lengthy process, but it's the best way of looking to see if a statement is valid. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics that you need me to cover, please let me know that as well.